Refraction through parallel multiple media. Refraction through parallel multiple media. That means if we have air, we have water, we have glass, and finally outside air. When ray of light is incident on first separating medium of 1 and 2, then we can say refractive index of water with respect to air. So N21 is sine of I1 upon sine of R1, correct? If I call this as I1 and here this is R1. So sine I1 upon sine R1 is refractive index of second with respect to first. This is I2. It will undergo refraction and go in other medium. So this is suppose R2. This is I3. And finally R3. So refractive index of third medium with respect to second will be sine of, this is I2 upon sine of R2. Should I draw the figure again?
No, sir, but when it goes from glass to air, it'll go away from the normal, right?
Okay, that too it is, we will write that way. It will away from the normal. In fact, it will become parallel to this. Second equation. When it goes from again air, glass to air. Air means again it is similar to first medium. Outside air, this also air.
Yes, sir.
So we can call this is same as first medium. So refractive index of air with respect to glass, that is third, will become sine of I3 upon sine of R3. When you multiply all N21 into N32 into N13, then we get sine I1 upon sine R1 into sine I2 upon sine R2 into sine I3 upon sine R3. Sine R3 will be same as this because they will be parallel. So I2, see this is I2, this is R1, both are same alternate angle. Hello?
So could you repeat?
Again I am writing, drawing for you. See. We are talking about what will happen if there is refraction through multiple parallel multiple media. Hello, Uns?
Yes, sir.
So again I am repeating.
Yeah.
So if it is parallel multiple media. 1, 2, 3, One normal from you, another normal. This is another normal outcome. So this is first medium, air. This is second medium, water. This is third, glass. Outside again, air. Always in same medium, ray of light will be parallel. So if this is one light making 30 degree, then parallel will also make same angle, 30 degree. These two angles, are they same? Because they are alternate angle. Correct? Hello?
Yes, sir.
This angle and this angle are the same, alternate angle.
Yes, sir.
Same way, these two angles are also alternate angle.
Yes, sir.
So if I call this as I1, this as R1, this as I2, R1, I2 are same. This is R2, this is I3, this is R3. So can I say N21 is sine of I1 upon sine of R1? I think clear now. Then going from water to glass, 3, 2, 2 will become sine of I2 upon sine of R2. Then last one, glass to air. So fourth medium is 1 with respect to 3. Is sine of I3 upon sine of R3. Any doubt till this? A simple Snell's law of refraction we have. Just draw this diagram and write this much.
Yes, sir.
Done full.
Yes, sir.
Shall I clear this?
Yes.
Therefore, multiplying 1, 2, 3, we get N21 into N E2 into N, last term is 1, 3 equal to sine I1 upon sine R1 into sine I2 upon sine R3 into sine I3 upon sine R3. See, sine I2 and sine R1 are same. Sine I3 and sine R2 are same. Correct now? So sine I1 upon sine R3, even these are same. Entry and exit, they are always parallel to each other if medium is same. I1 is same as I3, so it will get cancelled. What will get answer? 1 or not?
Yes, sir.
That means when you start from one medium and come out through same medium, always answer will be 1, whatever may be the medium. Now this if I write, it is N2 upon N1 into N3 upon N2 into N1 upon N3 equal to 1. This already we have done. Now what we can cancel?
So everything.
Yes, sir.
Yes, because it will become 1 only. So by this also you get same answer. Okay, 1 second. Huh? So that means whenever there is multiple medium but outer are same, then always answer will come 1. This is for entrance reactor. Now if I take this 2, N21 into N32 will become 1 upon N13. So from this you can write N21 into N32 equals to N. When you interchange, it will become reciprocal. N31, correct? Hello?
Yes, sir.
That means indirectly I can say refractive index of third with respect to second is third with respect to 1 and second with respect to 1. 1 means air, na?
Yes,
Hello?
sir.
Acha, एक second, एक line और. That means mu of suppose glass you are taking with water, we can write this is mu glass upon mu water. Follow na?
Yes, sir.
Just copy this one, then write no. Say in exam, as such, it will never come like this, but they can create MCQ asking you to find something. But remember, when outer both are same, then no need to consider intermediate. It is directly you can start from this and end of this.
Yes, sir.
Real and apparent depth. This is important for MCQ. Object when kept in denser medium and you are seeing from the top, it appears to be raised. Huh?
Yes, sir.
So whatever we see, that is apparent, and whatever is actual, that is real. So if I take a container filled with water and at the end there is suppose one source or point O. So to get its image, if I draw one ray starting from O, incident normally it will come out without any refraction. But suppose ray is incident at angle I, then it will not follow same path from denser to rarer, it will move away from normal. So when I extend this refracted ray and this first refracted ray, wherever I see the image, that is my apparent object position. This angle is I. Angle made by refracted ray with normal is called angle of refraction. This much, just draw the diagram.
Yes, sir.
Yeah?
Yes, sir.
This entire distance is called real depth, and A to I is called apparent depth. This is real depth. Heading outside. Real depth. Now this angle is I. What about this angle? Also I? Alternate angle?
Yes.
Now this angle is R, this total angle of refraction. This will be R, not total.
Vertically opposite angles. Yes, sir.
This one is vertically opposite angle. This total is R. When two triangles are similar, then we know corresponding sides are proportional. Yeah.
Yes, sir.
This is one parallel line, another parallel line drawn. This was that refracted ray I produced backward. So if this is R, even this is R, that means this angle is R, correct?
Yes, sir.
So I can say triangle A I C. A I C is congruent to triangle A O, no, similar to triangle. Similar to triangle A O C, because I is same as R and this is 90 degree. O, if I start from here, A I C is similar to A O C by a test of similarity. So this much, draw the diagram and write only till this.
Yes, sir.
Okay?
Yes, sir.
If triangles are similar, then corresponding sides are proportional. So I can say like this now. AI upon AO equal to AC. This is also same, AC equals to IC upon OC. AI upon AO equal to I to C and O to C. If you take reciprocal, then you will get this as, okay, one. If we are interested in proving refractive index is real depth upon apparent depth before doing this one. Diagram part I think we followed. No? What is sine I here? What will be sine I? From the figure, sine I. Is it in right angle triangle OAC? Sine I is opposite side AC upon OC. Okay.
Yes.
And what will be sine R? Opposite side AC upon AI. That means sine I upon sine R will become AC upon OC into AI upon AC. I can cancel AC, AC. Therefore, refractive index, it is going in second medium. Huh?
It's AC upon IC, right? The sine R.
Opposite side AC upon CI, CI.
So which angle is exactly I in this whole diagram? Because there are two I's.
1 minute. Wait, I'm just drawing the diagram to make it clear. This is container containing water. Here there is one object row. You want to get its image. So first ray drawn parallel, perpendicular to the surface, comes outward without any reflection. Second ray, this is normal. So actually this is I, this way. Then it undergoes reflection. Suppose you call this point as C. Produce this backward. So this is I. Now this angle is R. This angle is also R. Now follow.
Yes, sir.
So you can say refractive index of second medium, that is air. Now from water it is coming to air. So refractive index of water, air with respect to water, is sine I upon sine R. So this is nothing but sine I. What will be sine I? Opposite side AC upon hypotenuse OC. Okay, correct?
Yes, sir.
Correct, no? And for R, it will be again opposite side upon hypotenuse IC. Okay, so AC I can cancel, no?
Yes.
AC we can cancel. So we get refractive index of air with respect to water equal to IC upon OC.
Yes, sir.
Now since A and C are very close, therefore refractive index of air with respect to water is equals to IA upon OA. A and C are very close. So we can say refractive index of air with respect to water equals to IA is apparent depth and OA is real depth. So when you take ulta, then refractive index of water with respect to air will become real depth upon apparent depth. So refractive index of medium can be written as real depth upon apparent depth. Okay, now follow.
Yes, sir.
Copy this much.
So when you say that A and C are very close, is that a given condition?
See, whenever you are observing, then object that we are observing here, no? This without that we cannot get this. That means here we are keeping I. So I must be so close that this object and image are coinciding. That's why A and C are assumed to be very close. See, we are going to observe from here, no? That means this both rays should enter in my eye. So actually they are very close. Diagram purpose ke liye we have drawn path.
Oh, that's why I and C are one below the other.
Yeah.
Oh, okay, sir. Yes, sir, done.
Shall I clear?
Yes, sir.
Now we are interested in what is shift between the two. I'm just writing part I am removing. So refractive index of denser medium is real depth upon apparent depth. Shift is equals to real depth minus apparent depth. That means this is my shift, correct? Now object either ka either. So this is real and this is apparent. So difference is shift, correct?
Yes, sir.
So we can say shift denoted as notation D. D equals to real depth in bracket 1 minus apparent depth upon real depth. Real depth means thickness of this medium into 1 minus 1 upon refractive index of the medium. So shift is this linear shift is thickness into 1 minus 1 upon medium. Copy this part. This is very important. Shift is thickness into 1 minus 1 upon mu. 1 upon n here or mu 1 it is. Actually, I write usually mu because n we take frequency. No, right. N1 is one medium. Object is placed here. This is N2, other medium, N3, third medium, and we are observing from here. Such that this is D1, D2, D3. So these are real depth, and we are seeing the object through this. So for different layers of refractive index N1, N2, N3 having real depth D1, D2, D3 respectively. So all will show apparent depths up, up, up. So we can say since refractive index of medium is real depth upon apparent depth. Therefore, apparent depth is real depth upon refractive index of medium. Therefore, net apparent depth will be apparent depth due to first one, that is nothing but real depth D1 upon refractive index plus second one real depth D2 upon refractive index plus third upon refractive index. Copy this much. So if there are multiple layers, then net apparent depth will be apparent of first plus second plus third. That is real upon refractive index, real upon refractive index, real upon refractive index.
Yes, sir.
From this, the effective refractive index comma n is real depth, full real depth upon full apparent depth. Full real depth is d1 plus d2 plus d2, and full apparent depth we got d1 upon n1 d2 upon n2 d3 upon n3.
Yes.
Now the part which we are going to do, very important, usually one MCQ is asked on this or one numerical they ask. This also partially you have done in 10th. Its application you have not done in detail. Critical angle. Have you heard about ICU?
So what is that?
It is intensive care unit.
Oh, that way. Yes.
Yeah. What is this? Intensive cardiac care unit. When the person goes in these two, weekend or 31st December, when situation is critical, then he will go. No?
Yes.
If situation is critical, तो पेशेंट आने वाला है क्या जाने वाला है या बीच में लटक गया है?
जाने वाला.
It can be anything. Doctor will say keep the fingers crossed. The situation is critical. Unless until we stabilize that, we cannot say anything. So that means his situation is such that he can either come or he can go away. That means he is critical in his condition. So whenever ray is in between like this, ना तो समझ रहा है आ रहा है क्या जा रहा है, तो critical हो जाएगा. Let us see what does it mean in our physics. Critical angle. When ray of light travels from denser medium to rarer medium, it will move away from normal.
Yes, sir.
This is I, this is R, such that sin I upon sin R is always constant for same two medium. So when I increase I, this numerator will increase.
Yes.
So that means denominator should also increase. So this will go still away. At certain angle of incidence, ray of light comes on the surface of separating medium. This condition is called critical condition. And this angle of incidence is called critical angle. So when ray of light travels from denser medium to rarer medium, then angle of incidence at which angle of refraction becomes 90 degree is called as critical angle. Okay, followed?
Yes, sir.
When here second medium should be always rarer, otherwise this will not take place. So when ray of light travels from denser medium to rarer medium. When ray of light travels from denser medium to rarer medium, then angle of incidence at which angle of refraction becomes 90 degree is called as critical angle. That means critical angle is actually angle of incidence, but a particular angle of incidence at which angle of refraction is 90. Just write the definition.
Yes, sir.
Yeah, everybody had done it.
Yes.
Show that refractive index of denser medium with respect to rarer is 1 upon sine of critical angle. This is very important for students. By Snell's law of refraction. Refractive index of second medium with respect to first is sine I upon sine R. This is fixed. In critical angle, second medium is always rarer and first medium is denser. Is sine I upon sine R. When I becomes critical, then angle of refraction becomes 90 degrees. So refractive index of rarer with respect to denser is sine of critical angle upon sine 90. When I take reciprocal, both sides I get sine 90 upon sine C. Now this is nothing but refractive index of denser with respect to rarer, sine 91 upon sine C. Okay, followed?
Yes, sir. So I have one question. So like in 10th standard, instead of and we wrote mu, like that sign, that mu sign.
That's what I told. I am also familiar with mu because n we use mostly for frequency in other chapters.
Yeah, sir, exactly.
N or mu both are valid. Whichever you want, you can write. I'm writing n because your school college teacher may not cancel your mark.
Oh, okay. Thank you, sir.
You can.
Yes, sir.
Total internal reflection.
Oh, sir. So the teacher, they told us the chapters for the test, 20 mark test.
When it is?
So they didn't tell us that, but mostly it's chapter 14 and 16.
15th is not there.
So we are doing 15 now, no?
We are doing 15, but your teacher has skipped 15 full.
Yeah, so today in class we started doing the lenses chapter, refraction through lenses.
That is 16.
Yes, sir. We skipped this chapter and we started lenses directly.
Yes, sir.
No, we can't skip for our entrance now. So this will take hardly one lecture, don't worry. When is your exam? You tell me that.
Sir, we don't know yet, so but
So it
See,
will,
we have completed 14th full, okay? The 16th also I will be able to complete. It won't take much time. Now for this second part, it is hardly something left out.
yes, sir, it's definitely more than 10 days away, 10, 12 days at least.
So I will be able to complete comfortably. See, we are not doing only as per the college, na? We are doing even as per JEE. So if I skip anything, that things are there in JEE.
Yes, sir, but
And don't worry, before once your date comes, I will take extra lecture and complete if it is not completed. So
yes,
total internal reflection. If this is mirror, light is incident on the mirror, it will rebounds back. No? Hello?
Yes, sir.
In this case, some energy of light or intensity is wasted. Mirror absorbs that. But total internal reflection means what? First of all, it is not reflection. It is actually refraction. So when ray of light goes from denser to rarer, it moves away from the normal. When angle of incidence is critical, then angle of refraction becomes 90. When you increase beyond this, ray cannot go in the other medium, it will come back to the same. This phenomenon is called as total internal reflection. Advantage of this, intensity remains same of incident and refracted. So when ray of light travels from denser medium to rarer medium, then if angle of incidence is greater than critical angle, then the ray of light comes back into the same medium. Comes back into the same medium. This phenomenon is called as total internal reflection. Please write this. It's called as total internal reflection. See, next week na entire 16 chapter ka theory I will complete, and then I will start with numerical of both this chapter together. So you are on the proper zone, comfortable zone for exam.
Okay, sir. Yes, sir, done.
Applications of total internal reflection. First is reflecting prisms. This you have done in 10th. Reflecting prisms. Hello?
Yes.
What is refractive index of glass?
That's 2.1, 2.25, right?
No, 3/2 or 1.5. No? Therefore, critical angle will become 1 upon refractive index of glass with respect to air. So critical angle will become 1 upon 3/2. That means critical angle will become 2/3, which is 0.666 recurring. This is C equals to sine inverse of 0.667. This comes nearly approximately 42 degrees. So if I can incident light at angle greater than 42, then it will show me total internal reflection phenomenon.
Yes, sir.
That principle is used in reflecting prisms, which are used in binoculars, reflecting prisms. In binoculars, we get 180 degree return back. That means ray of light get reflected back at 180 degree. In periscope, they get reflected back by 90 degree. Why? Because if we have arrangement of light to be incident in such a way that angle of incidence becomes greater than 42 in the glass prism, then it will show total internal reflection. So just write down this, then I'm explaining further. So we got idea critical angle for glass is nearly 42 degree.
Yes, we're done.
Thus, critical angle for glass is about 42 degrees. When 45 degree, 45 degree, 90 degree prism is incident with light on its perpendicular side, then it falls on hypotenuse. This is 45, so this angle will be 45, even this will be 45.
Yes.
It falls on the prism on the hypotenuse at an angle of 45. Thus, angle of incidence, because it is 45 degree, it is greater than 42. So it shows total internal reflection, that is I equal to R. So it comes downward with angle of 45. Thus, this principle is used in periscope so that light gets turned by 90 degree. So if we call this as PQ, this will be RS reflecting back at 90 degree. But suppose light is incident on hypotenuse. It's incident on hypotenuse. Now tell what will be this angle here? Still 45. So it will fall on this. Now if I draw here normal, this is 90, this is 45, this is 45. So this also 45. It comes back by reflecting again. So is it 180? We make light incident on right, it turned back on the left. So if you consider this beam of light, it will turn back by 180. Okay, followed this two diagram.
Yes.
So
So,
where is the
huh?
second diagram used?
That is used in binoculars, and first one is in periscope. Periscopes are used in submarine, so that light, they make the periscope move slightly up above the light, that means above the water. Light comes incident and bend at 90 degrees so that they can see inside. Hello?
Yes, sir.
See, imagine if this is T-shaped something this way. So light comes here, bends by 90 degree twice. So this is in air and this is inside the submarine. So they can see that also.
Sir, and there are mirrors at the corner, right?
Here there will be prisms at this corners.
Okay, sir.
Just draw this diagram.
Yes.
Right. In reflecting prisms, the light can be reflected at 90 degree or at 180 degree. As shown in first case, the prism is adjusted in such a way that light turns by 90 degree. This principle is used in periscopes. As shown in second case, the prism is adjusted in such a way that light turns by 180 degree. This principle is used in binoculars.
Yes.
Mirage formation, you know, no?
So can you just show that once?
One minute, I'm explaining. Formation of mirage. Actually, it is illusion that there is water and object is having shadow in the water. Huh? See, during summer season, the air will move up due to heat. Because something is heated, it becomes lighter, so it moves up. That means this will become rarer medium close to the surface, and the top it will become denser medium. Correct? This much okay? See, this is entire air column. But at higher temperature, this air column will get squeezed here, and here it will be spread. So this is denser and this is rarer. Correct?
Yes, sir.
So I can say during summer, in desert, the sand or road surface becomes very hot, so the air column moves upward. So close to the surface, medium is rarer, and above to the surface, it is denser. So when rays of light comes from distance object, it goes from denser medium to rarer medium and shows total internal reflection. Thus, a person feels that there is shadow or water in which the shadow is formed. This is called mirage formation. Okay? Hello?
Yes, sir.
See, वापस ये tree है suppose. A person is observing from here. So light will come from denser to rarer on the surface. Then it undergoes total internal reflection. So he assumes that there is something coming out from here. तो उसको उधर shadow जैसा दिखता है. तो ये watery दिखता है. So when you have traveled through highway during summer season, if you see from far distance, so we feel that there is water. That is nothing but mirage formation.
Yes, sir. Yeah, we see it often.
So this trees all they we feel it is inverted due to illusion effect of total internal reflection. This is called mirage formation. Okay, this will do on your own. This mirage वाला.
So
चलो
like actually, sir,
नहीं मैं दिखाई देता हूँ आपको. So that this book will is your entire notes intact. Nothing to see from anybody. Anything else. Right. Formation of mirage. First meaning of mirage. Right? It is optical illusion. It is optical illusion occurring in desert or during summer on roads. The object appears inverted. The object appears inverted to a distant observer. Who feels the object inverted in water. This illusion is called mirage. Which is due to phenomenon of total internal reflection. Total internal reflection. Third one they can say sparkling of diamond. Why it happens? Sparkling of diamonds or sometimes brilliancy of diamonds. So diamond's refractive index is 2.44. So when you find its critical angle, it comes to be nearly 24. So diamonds they are cut in such a way that when light enters, that angle of incidence becomes greater than 24. So it undergoes multiple reflection. Because of that, we feel it is sparkling. See, they are cut in such a way, diamond, so that when light enters, that angle is greater than 24. When this happens, it undergoes multiple reflection. So under both सा light दिखता है, we feel it is sparkling. This is due to total internal reflection. Right. The refractive index of diamond is 2.42 and its critical angle is 24. The diamonds are cut in such a way that when light enters, it undergoes multiple reflection and hence diamond sparkles due to total internal reflection.
Yes, sir.
Now, one application which is frequently asked, optical fiber. So either they can ask you one liner, filling the blanks. The working of optical fiber is based on dash or shortcut. Optical fibers. It works on the principle of total internal reflection. Now see what it is made up of. See, this is circular part I cut vertically. तो मुझे ऐसा दिखने वाला है खाली. When I cut vertically, मतलब इधर थोड़ा thickness, इधर थोड़ा thickness है ना. So do you fly kite? No.
Yes, sir.
So suppose that kite is like cylinder. Kite का वो what is that called? फिरकी बोलते हैं ना उसको कुछ. Suppose I'm saying suppose this is cylinder. ठीक here. When I keep it like this, the cylinder. When I cut by vertical plane, so I will be able to see only this much part, not like this. There are thickness. Can you imagine this?
Yes, sir.
It consists of. It means this optical fiber is usually made up of thin glass fibers of nearly 1 micrometer in diameter. Diagram it is enlarged, but it is thin fiber, nearly 1 micrometer. It consists of central core, central cylindrical part called as core, made up of material having refractive index 1.7. Outer surface is coated with another glass-like material but of refractive index less than 4, 1.6. This is called as cladding. It's called cladding. So inside is core, outside is cladding. When ray of light enters through this end, then due to refraction first it will fall on this. Now it is moving from denser medium to rarer medium. Okay. Core is 1.7, cladding is 1.6. So light is going from denser to rarer. Hello? Hello?
Yes.
So suppose this angle of incidence is large. अब इधर क्या करते हैं वो लोग, एंगल ऑफ इंसिडेंस को बहुत स्मॉल कर देते हैं सो दैट इट मूव्स अवे. तो ये if this is more, this is very small, so this is very small, this will be large, na? Hello, hello, hello.
Yes.
फिर से देखो, नहीं समझा तो. It works on the principle of total internal reflection. It is made up of glass fiber, usually of diameter 1 micrometer. Each optical fiber consists of central cylindrical part called as core, made up of material having refractive index 1.7. Outer surface is coated with another material of refractive index 1.6 called as cladding. When light is incident at very small angle on the surface, it moves from denser medium to rarer medium at angle greater than critical angle and shows multiple internal reflection. Thus, it is made to pass from one end to another with the speed of light. So this is optical fiber. Hello?
Yes.
So we can propagate any signal by superimposing with light with the help of optical fiber, because it undergoes total internal reflection and ray of light can travel. This follow?
Yes.
Right,
Yes.
first line. It works on the principle of total internal reflection. It works on the principle of total internal reflection. Next line. It is made up of thin glass fibers having diameter usually 1 micron. Having diameter 1 micron. It consists of central cylindrical part called as core, made up of material having refractive index 1.7. The outer surface is coated with another glass material. Outer surface is coated with another glass material having refractive index 1.6 called as cladding. Next time. When ray of light is incident at very small angle with the surface. At very small angle with the surface. Then inside the fiber, it travels from denser medium to rarer medium at angle greater than critical. At angle greater than critical. Due to total internal reflection. It undergoes multiple reflection. It undergoes multiple reflection and comes out of the fiber. Then draw this diagram. Draw this diagram, then few application we are doing.
Yes, sir.
Right. Applications. First one, a bundle of optical fibers. A bundle of optical fibers called as light pipe. A bundle of optical fibers called as light pipe is used to transmit the image of an object to large distance. It can be used for endoscopy. Is what doctor does. He passes through the throat to light pipe. Through one, light is incident and then it is reflected back and seen on the screen of computers by using this. Third, it can be used for transmitting and receiving TV signals. So we have completed this chapter number 15, theory part. Again, numericals. Solved one you all try. Whichever you don't get, I will be explaining.
Okay, sir.
Just one sum I am explaining because it is very important. You may not understand, or if you understand, it will be long cut for you. Just I am showing you. Can I clear this now?
Yes, sir.
So now comfortably I will be able to complete that chapter 16. Don't worry. They say there is a fish at height of h from the top of surface, at depth of h. There is a fish. This fish is seeing upward, feels there is horizon. So what is the radius of horizon, or area of horizon, or diameter, they can ask. Horizon means the fish feels that there is only light here, nothing beyond that. So when it is, the fish is seeing upwards, if light undergoes to critical angle, light is incident at critical angle, then this side will be light, this side will be light, उसको इधर अंधेरा दिखेगा, तो उसको लगेगा ये horizon है. So suppose this is R, this is angle of incidence, which is nothing but critical angle. So if this is I, this is I, that is critical angle. So I know refractive index of denser medium with respect to rarer is 1 upon sine of critical angle. If I denote this as mu, then it is 1 upon sine of critical angle. So sine C is 1 upon refractive index. Suppose we consider one triangle. This angle is C. Then sine C is opposite side 1. I put in is mu. This will become root of mu square minus 1. Okay? Hello?
Yes, sir.
What will be tan C in a triangle? Tan is opposite side upon adjacent side from triangle.
Yes, sir.
But from figure, tan C, I can write opposite side R upon H. Correct or not?
Yes.
So R upon H will become 1 upon root of mu square minus 1. Therefore, R is H upon root of mu square minus 1. So whenever it is the sum given, a fish is feeling there is horizon, then you can directly start that H upon root of mu square minus 1. So very important sum, or numerical or MCQ they can ask. Draw the diagram and then copy full.
Yes, sir.
Done. Ramsey, I will be able to complete 16th also before month end. After 16, even optical instrument has to be there. Completed full?
Yes, sir.
Last sum and do it. Unsolved one. See, can you see 14th sum of MCQ? 14,
So could you say the page number?
658. A fish which is at depth of 12 centimeter.
Yes, sir.
A fish is at depth of 12 centimeter in water of refractive index 4 by 3 is viewed by an observer on the bank of lake. Oh, apparent depth वाला है तो बहुत easy. I thought वो critical angle वाला है. This is easy. Find what will be apparent depth as observed by the observer. Apparent depth. So refractive index is real depth upon apparent depth. Apparent depth is real depth upon refractive index. Real depth is 12. Refractive index 4 by 3. So it is 12 into 3 by 4. 4 into 3, 12, 9 centimeters. Okay.
Yes.
So that's all for today. Sunday you have test on this chapter, and Monday I will do sums from this only. Wednesday onwards I will start with refraction through lens. Or first I will complete theory and then I will start with numerical. Hello?
So Sunday, what test?
Sunday as usual you have test chapter number 650.
Theory and I mean
No, theory and theory and just simple sum. So next entire week now what I will do till optical instrument. First I will complete theory. Then I will start doing numerical analysis. So that let your teacher keep test whenever he wants, you are comfortable.
Okay.
Okay then. Bye. Take care.
Bye, sir. Thank you.
Bye. Thank you.
Bye.